Hello dear students, very good morning. In the last class we have seen many things on flexible pavement. Okay, just we will see today certain additional information about flexible pavement, like maximum wheel load. We have seen everything, but the wheel load configuration are important to know the way in which given vehicle are applied on the pavement surface. Typical wheel load configuration of tractor trailer unit of a heavy duty vehicle is as shown in figure. This is considered as heavy duty vehicle. So when tractor and trailer units are plying on road, plying, P-L-Y-I-N-G, plying, not playing, plying, not flying either, then how the load distribution is to be considered also an important factor. As specified by IRC, Indian Roads Congress, the maximum legal axle load for highway is 8170 with a maximum equivalent single wheel load of 4085 kg. Instead of total 8170 kg, which is transferred onto the pavement, hardly half of it will be transferred because of the concept of equivalent single wheel load that we have seen. Total load influences the thickness requirements of pavements and tire influences the wearing course. Therefore, the magnitude of vertical pressure at any depth of soil subgrade mass depends on the total load and the surface pressure. Based on the business theory which you have studied in foundation engineering, probably I might have taught to you, I do not remember. To uniformly distributed circular load is as follows. Sigma z is equal to P whole multiplied by 1 minus z cube divided by a squared plus z squared whole to the power of 5 by 2, where sigma is vertical stress at the depth z. Suppose if you consider this is the subgrade, this is the load which is applied either W or P, then at vertical depth, at any position, suppose if you consider here, then this is R, small r, this is the depth Z at which the pressure is developed. So, or vertical stress developed. P is the surface pressure, so W by area of application of the loading. Then Z, depth at which vertical stress is determined, that means at this point, where A is the radius of the loaded area, where A is the loaded area. R is the horizontal distance at which it is computed with respect to the vertical axis. This is the vertical stress distribution in terms of pressure, vertical stress and the depth. So this dotted line curve, dotted line curves indicates for, and bold line curve indicates for different tire pressures, the vertical stress computed at different pressure level. Contact pressure, this also you have seen, it is nothing but the ratio of load on wheel of contact area or of print, load on wheel divided by contact area or area of imprint. Imprint is considered usually an elliptical instead of circular. This is not being considered. Elliptical shape is considered elliptical. elliptical shape is considered. Okay, these are all we have completed. This is also completed. This graph also we have seen. Depth d by 2. These are the two coordinates, d by 2 and p. Here z is equal to 2s and 2p is the magnitude. At any depth we can calculate what is the load or the stress. So you have to come from the abscissa, touch the curve, and then this is assumed as straight line curve. Straight line curve. This is similar graph. Okay, we have already seen this. Further, any important points which we can get it from here, from other reference, we are looking for. Okay, here also how the equivalent wheel load factors can be considered. We have to make use of this plot. But however, in exam, these values will be given, because while making approximation it would be very difficult. So radius of relative stiffness, this we come across in case of rigid pavements separately, but however, what it is, stresses due to curling and warping depend on the ratio between the length of the slab L and the radius of relative stiffness. The radius of stiffness L is provided by the equation 4th root of EH cube divided by 12 into 1 minus mu squared into K, where E is the Young's modulus, H is the thickness of the slab, K is the modulus of subgrade reaction, mu is the Poisson's ratio of concrete. Modulus of subgrade reaction, we know, we have already studied in foundation. It is nothing but the pressure at the deformation level of delta is equal to 0.125 centimeter or 1.25 millimeter. 0.125 centimeter, I am right. Okay, this we already learnt. Just we are glancing, remembering, recalling what you have already learnt in the previous classes, maybe in the name of other subjects, but it is most related to this subject. Guidelines for design by IRC 37/2012. This is the recent one that also we have studied in detail. Okay. Traffic growth rate, etc. We have seen design life N, vehicle damage factor, VDF. It is a sort of a revision for you in order to get some other information or knowledge about this relatively related topics. But these are all becoming a revision for you now. Okay, number of standard axles for same damage factor, load axle divided by standard axle load to the power of 4, everything we have seen in the last class itself. In the previous class itself we have seen all these. Sample size for the survey, if it is less than 3000, it shall be 20%, 3000 to 6000, 15%, more than 6000, total number of commercial vehicles per day, it is 10%. All this we have seen. Lane distribution factor was completed. Vehicle distribution, everything is completed. Even this formula was explained in detail except N, A, D, F. I asked you to send it through Google platform, but unfortunately due to some or the other technical or practical reason, I could not put the question on the Google Classroom platform. Today I will be going to post it. Please answer what is N, what is A, what is D, etc. Okay. A is equal to P into 1 plus R whole to the power of N. Everything we have studied. Even these curves are recently developed that you have to follow anyway. All those constant values will be given in exam because it will be difficult to assess the papers, is it not? For examiners it will be more difficult. That's why certain values are not given to your freedom to assume, it will be given. There is a numerical problem which is solved that we have already solved in the previous class itself. Design guidelines for the flexible pavement IRC 37 2012. This also we have seen in detail in the last class itself. Consider the design. These are all, I told you, certain things are self-explanatory that to your at B level, you yourself can go through these. Stresses in flexible pavement. Vertical stress, contact pressure. Vertical stress, this formula we have already seen. The figure also is being given here. Right? This is beyond your scope. Contact pressures we have seen. Tire pressure, inflation pressure, contact pressure, all are almost same. So contact pressure is equal to load on wheel divided by contact area or area of imprint. As I already told, instead of circular, we go for elliptical. That's all the difference. Okay, boy. Okay, students. Okay, students. Factors affecting design pavements. We have already come across just certain other factors which may be available in different references we are bringing in front of you. Climate, that is with respect to rainfall, temperature, frost action, design wheel load, we have seen in detail, environment, height of embankment, foundation cutting, geometry, pavement materials, they have to resist conditions, durability and maintenance, subgrade soil decides thickness of the pavement, etc. etc. Factors influencing skid resistance, naturally weather, seasonal effects, temperatures, age of the pavement, contamination of the pavement surface, weather. These are all self-explanatory, just I do not wish to read the printed sentences. I already explained at the beginning itself how they impact or how they affect the pavement, whether flexible or rigid pavement. Temperatures, age of the pavement, especially age of the pavement surface can also be a significant factor. New pavement surface relying on exposed aggregate faces for skid resistance provision tend to polish under traffic action most rapidly in the first year, leading to a negotiable decrease in the skid resistance. Combination of the pavement surface. Design approach for flexible pavement California bearing ratio method. So this method was not available in those PPTs which we have covered. That's why it is taken separately. Now we will see how this CBR method can be used for the design of flexible pavement. Okay. GI method, group index method nowadays has become obsolete because it depends on only the physical properties. Then question arises, if we design the flexible pavement based on group index method, then the question arises to what extent it can sustain the load coming over it, since it entirely depends on the physical properties, not on strength properties, because no strength parameters are evaluated under group index method. In the earlier decades, group index method was the first and foremost method for flexible pavement design. Okay, as the researchers have undertaken so much of research works and they came out with good respondent behavior of the flexible pavement based on, if it is designed based on strength parameter, it would really serve the purpose for the society after it is being constructed. So CBR method also considers the characteristics of subgrade and properties of materials forming the various courses of the pavement. CBR is an empirical test devised by California State Highways Department, USA, which a property of the subgrade is measured. The method of test is also standardized by Indian Standards of Institute, that is ISI. This is performed on a sample of the subgrade soil in a standard loading device. The device measures the load required to cause the penetration of plunger of 2.5 millimeter. This we have already studied in the virtual lab. However, the summary of this method, which may be implemented for the design of flexible pavement, we will see. Cross-sectional area of the plunger becomes 1960 millimeter squared. Rate of penetration of sample by the plunger is 1.25 millimeter per minute. They should have been square millimeter because area. Penetration to the sample by plunger is of 2.5. Required penetration 2.5 mm. The pressure at the penetration level 2.5 mm, which we have already seen, calculated, and it is expressed as a percentage of unit standard pressure, and this percentage of unit standard pressure is called as CBR. Test is repeated for the penetration of 5 mm and then CBR is found out. Higher value of CBR is preferably considered. The value 2.5 mm penetration is generally higher. If it becomes at 5 mm penetration level, the value of CBR is higher, then 3 more additional tests is required to be performed and average of 6 trials has to be evaluated. If that also again repeats that the maximum value of CBR is at 5 mm penetration, then that is to be adopted. Otherwise, at 2.5 mm penetration level itself, the value of CBR becomes or observed to be higher than at 5 mm penetration level, then that is adopted. The unit standard loads at 2.5 mm penetration level is 70 kg per centimeter or 7 Newton per millimeter, and the unit standard load at 5 mm is 105 kg per centimeter or 10.5 Newton per millimeter. Okay. IRC adopted CBR design chart is also shown in various figures. What we have referred from the book is figure 6.5.2. There are 7 curves. It is based on, or these curves are followed by just on Kana, if I remember. 7 curves from A to G for different volumes of traffic to be carried by the pavement is as shown in CBR method. CBR method, wherein CBR design chart is available. The traffic is taken in units of heavy vehicles. Heavy vehicles means heavy commercial vehicles per day, whose laden weight is about 3 tons at least and greater than 3 tons. Equal to or greater than 3 tons only is the commercial vehicles to be taken into account. With a laden weight I have already mentioned. If value of CBR of material of the component layers of pavement is different, then component layers can be suitably divided with the help of same curve as shown in figure. Splitting up the component layers of pavement due to materials with different value of CBR is a serious disadvantages of this method, and hence the total thickness of the pavement above the subgrade remains the same even though the quality of materials used is good or moderate or bad. So irrespective of the intermediate layers in which the materials are used, irrespective of the quality of such materials, the total depth of the flexible pavement is entirely dependent on the CBR value of soil subgrade. Hence that is the disadvantage, yes. Or limitation we can call. Traffic is classified for CBR design curve A, B, C, D up to 15, 15 to 45, 40 to 150, 150 to 450. Advantages. I have already said during the experiment itself in the virtual lab itself, limitations, etc. You yourself can read. Limitations also I have explained sufficiently. There is no scope now. Wheel load stresses, Westergaard stress equation. So these we can see in rigid pavement. So let us continue this in the next lecture class. Okay. Thank you. Have a nice day. Have a nice day. Have a nice day. Thank you. Have a nice day. Thank you. Have a nice day. परमात्मा सिद्धि विनायक लक्ष्मी सरस्वती वेंकटरमण स्वामी वेंकटाचल